I am in the purple in your pie, and it is the solving equations, linear equations and inequalities. Again, the title said solving involving one, many, or no solutions for these. When you solve an equation, three things can happen. My pen's a little slow today. I think it's the Wi-Fi. Okay, so when I solve an equation, three different things can happen. This is not happy today. I don't know why. Yeah. Okay, case one, you can get one solution. So that means that you go through and you work the equation like x plus 4 equals 9. You subtract 4 from both sides. You get x is equal to 5. One solution. One thing happened. Okay? Case 2, you can get no solutions. And these were the ones, Megan, you were working on the other day. Okay. Case 2, you can get no solutions. So what does it look like when I get no solutions? Well, you're going to have an equation maybe like this. 3x plus 4 equals 3x minus 2. So when you go to solve this equation, I like to do variables first. So in this case, I would subtract 3x from both sides. Subtract 3x. Subtract 3x. What's 3x minus 3x?
Does it matter what if there are two different numbers?
Well, these are the same numbers. So what's 3x minus 3x? What do you get? No, you don't get an x. You get 0. You have 3x. You take 3x away. You have nothing. So what's 3x minus 3x? 0. So notice that the variables on this one zeroed out. 3x minus 3x is 0. So what I'm left with now is the number 4 on the left side and the number -2 on the right side. So my equation now says something crazy like 4 equals -2. It doesn't, right? It doesn't. So that is a false statement, okay? It's a lie. And so that tells me that there is no solution. My variables zeroed out 3x minus 3x. And so it's no solution, not no solution. So there is no solution because what I ended up with was not the truth, right? Not the truth. Okay, so that's case 1 and case 2. So case 3, the title of this said, I either get one solution, no solution, or infinitely many solutions. So that's the next case. Case 3, what does it look like for me to get infinitely many solutions? So for case 3, boy, this is really dragging. You saw how slow that was? Infinitely many solutions. Okay, so how will that look? Well, I'll start off with an equation like 5x plus 2 equals 1 plus 5x plus 1. Okay? So I have 5x plus 2 equals 1 plus 5x plus 1. So what's the very first thing I can do for this one? What should I do first?
Subtract 5x.
I could subtract the 5x, but whenever we're solving equations, if we see some like terms on the same side, we need to put those together first. So y'all see how I have a 1 and a plus 1 right there, like terms? I need to put those together first. So that will give me 5x plus 2 is equal to 5x plus 2. Okay, so those of us that are really observant and pay attention, what do you notice about the equation right now? It's the same exact thing on the left side and the right side. Y'all see that? Okay, so that tells me right there it's an identity. That means the left side is equal to the right side. So it doesn't matter what number I put in. I could put in 0 and it's going to be true. I could put in 1, it's going to be true. I could put in negative 10, it's going to be true. So this equation will have infinitely many solutions. So let's say that at this point you didn't catch that and you kept working, right? So then, Megan, I'm going to do what you said, which was let's go ahead and subtract 5x from both sides. So I will subtract 5x from the left side, subtract 5x from the right side. And what do I get when I have 5x minus 5x? 0. So that's a 0. 5x minus 5x, that's a 0. So what am I left with? 2 equals 2. So this time, instead of it being a lie, false, it's true. So that tells me right there it's an identity. And so my answer would be infinitely many solutions. You might see all real numbers. I don't know. So infinitely, that is not how you spell that. Let's just pretend it is. Infinitely many solutions. Okay. Or all real numbers for the solution. Either one. Okay, now I want to flip back real quick. I want y'all to look at the problem that you're given in your homework set. This is the problem from the homework set. It says, decide if it's no solution or y equals, that means one solution, or all real numbers are solutions, that's your infinitely many, okay? Now, notice that the equation that they've got for us in that first box, you have 2 equations to try. We're going to try that first one because it's got a lot of junk in it, the parentheses and all that stuff. And so I'm going to write that one down, and we are going to solve that one. You guys write it down, and you solve it and see what you think the answer is. And I'll solve it. And we will see if we get the same solution. Okay, so we're working -3 times y plus 5 plus 5y equals 2 times y minus 6. So write that equation down and y'all start working on it. And decide if you think it's no solution, all real numbers are solutions, or one solution, y equals something.
The first one?
That top one, -3 times y plus 5 plus 5y equals 2 times y minus 6. I'm going to flip back to my iPad. And I have the equation written up at the top if you didn't get a chance to write it. It's up there. So see what you get. Okay, my first step is going to be to distribute the -3. And so that's -3y minus 15 plus 5y. I didn't touch him, okay? He doesn't get that -3y distributed. And then I'll distribute the 2. So that is 2y minus 12. 2 times -6 is -12, okay? So now on the left-hand side, you should have noticed that you had some like terms. You have a -3y and a positive 5y. So putting those like terms together, that's going to give me 2y. So I have 2y minus 15 is equal to 2y minus 12. So at this point, can you guys tell me what the answer is? You should be able to. No solution. Okay, because what's going to happen?
The 2 y's.
That's right. The 2y's are going to zero out. And so you're going to get negative 15 is equal to negative 12. So no solution on that one. Very good. Okay, that's all I wanted for today. Y'all can get to work. I'll walk around and help you if you need some help. And for this one, we know we get no solution. And I will